Hey everybody, it's Mr. N, and this is part 6 in our series here for the 2024 Quick Reviews. This is another FRQ with a calculator required, and it says the temperature in Mr. N's classroom can be modeled by T of H equals negative A minus B cosine pi H over 12, where T is the temperature in degrees Fahrenheit and H is the number of hours since midnight, where H is constrained between 0 and 24. And in part A, it says the initial temperature at midnight was 50 degrees, and at noon it was 70 degrees. Find A and B. So what this problem is telling us right here, since at midnight this would be T of 0 is going to be 50, and at noon this would be T of 12 is going to be our 70, and we need to find A and B. So since we know this, we can say, all right, well, T of 0 is going to be, let's put 0 in our equation that's right over here. So if I put in 0 for H, I will get the cosine of 0. So let's go ahead and write all this in. So this is going to be negative A minus B cosine 0, and the cosine of 0 will yield 1, so I'll end up with 50 equals negative A, so this yields 1 minus B. And then if I did it at 12, I get T of 12. This would be negative A minus B cosine, and now this would be pi 12 over 12. So this would be the cosine of pi. So then this answer would yield 70 equals, having a little glitch here, negative A minus, now the cosine of pi would be negative 1. So this would yield negative 1. So this would be plus B here. And now this just becomes a simple algebra problem for this question. So I can set this up as 70 equals negative A plus B, and 50 equals negative A minus B, and I can go ahead and solve for this. I will get 120 here equals negative 2A, so I'll get a value for A as being negative 60, and I can plug this back in, and I'll get a value of B equaling 10. So that was pretty straightforward, pretty easy. It was more of an algebra problem, nothing too crazy there. All right, for the next part, it says, find the average temperature for the first 10 hours. Okay, so the average temperature in this case would be an average value function again. So this would be 1 over the t minus 0, since we are going from 0 to 10, right? And in this case, it would be, again, the integral from 0 to 10 of our equation here, which is, remember, our T of H equation became now, when we plugged in these initial values, so negative A, so this would be 60 minus B, so that'd be 10 cosine of pi H over 12. That's what it would be there. So let's write that in. So that's 60 minus 10 cosine of pi H over 12 dH in this case. And plugging this into my calculator would yield a value of 58.09 degrees Fahrenheit. All right, moving on to the next question. And here now it says, use the trapezoid rule with 4 subdivisions to estimate from 6 to 8 of THDH. All right, well, this is a little bit different since it's saying 6 to 8. It's not saying 0. So we need to determine what our spacing is. Well, our delta x is our spacing, right? And in this case, we will have b minus a over n. Well, n is 4 subdivisions. So this gives me 4. And in this case, there's my A, there's my B. So 8 minus 6. So that's 2 over 4. So my delta x spacing is 1/2. And since this is a function here, it's delta x equals 1/2. This will be even spacing. So I can use shortcut formulas to help me out. So this tells me that I need some values here. I need t of 6, that's my starting one, and since it's 1.5 spacing, since it's half spacing, I need t of 6.5, t of 7, t of 7.5, and then finally t of 8. Now, if you quickly took a look at the graph of this, now this is the spacing that I need, and I'm putting these into a quick sketch based on values I have. You would see that this is strictly increasing. So if I said that this is 6, I could put a value there, then I would need 6.5, 7, 7.5, and 8, and that would give me the evenly spaced subdivisions, and since this is strictly increasing, I would get trapezoids that would look like this. Oops. And there are 4 trapezoids there. So that's what would happen, and each of these would have a delta x of 1/2, and since they're evenly spaced, you could go ahead and, if you wanted to do this in a different manner, you can find the area of each one of these just using your basic formula, because you could get the height, the base here. This is going to be our height, and these bases, right? This is base 1 and base 2. Then keep doing it. Find every single one separately. You could do that. If you wanted to use a trapezoid rule formula, then we would have to do the following. We would say the trap rule would give me the integral from 6 to 8 of t of h dh. That would give me the area, and that would be delta x over 2, and this would be the first is t of 6 plus 2 times the second, which is, oops, let's clean that up a bit here, put this correctly. This would be 2 times the second, which would be t of 6.5, plus 2 times t of 7, right here, and then plus 2 times t of, I keep doing that, t of 7.5, and then plus 1, because this is the end, t of 8. Now remember, in the trapezoid rule, the ends have 1, but everything in between have 2 times. And you can only really do it this way if it's evenly spaced, which this is. If it's not evenly spaced, then you would need to find each one separately. Now, typically on the AP test, this is a different question. They've done this before, but they've also done ones where they give you the table, and in the table of values, it's not evenly spaced, so you need to find every single trapezoid separately in this manner that I had described earlier. All right, so now, continuing on with this. So let's take a look at what we got here. And this would be, since I have delta x is 1/2, this would give me 1/2 times 1/2, right? Because delta x is 1/2, and I already have the delta x over 2. Now, the delta x over 2, this over 2 part is part of the trapezoid formula, because, again, it's base 1 plus base 2 divided by 2 times your spacing. So base 1, base 2 divided by 2 times your spacing. So that's just a little background where that came from, and we know that. So already, and let's go ahead and clean this up. So 1/2 times 1/2, and this ends up being, let's find t of 6. I'm going to use my calculator. Now, here's what I suggest always. Put the equation, this one right here that we cleaned up and found right here, put that into your calculator as y sub 1. You can graph it and then find these values strictly from your calculator using the second calculate feature. Okay, so from your graph, you can calculate the values at each one of those points, and it's much quicker to do it that way. So t of 6 comes out to be 60 plus, this is going to be 2 times 61.3052 plus 2 times 62.5881 plus 2 times 63.8268 plus the 65. Now, cleaning all this up, I will get 1/4 times 500.0 0.4402, which would give me a value of 125.1101 using the trapezoid rule. All right, let's move on to the next question. And it says find an expression for the rate at which that the temperature is changing with respect to h. Well, it's a rate that's asking for the temperature change. Since it's a rate, that's t prime, which is our dt dh. That's what they're asking us to do here. And looking what our t of h formula was, t of h, they told me was, when I found it up above, this was going to be the 60 minus the cosine 10 times the cosine of pi h over 12. That was my formula that I had discovered after I found a and b. Now, taking this t prime of h, which is my dh dt, I will get, well, the 60 goes away because that's a constant. Over here, the derivative of cosine is negative sine, but then I have this negative out there, so I'll get positive 10 sine, and this was pi h over 12. And then I need to chain rule this, so this will give me pi times the pi over 12 here as the chain rule part. So now cleaning this up, I will get dt dh equaling, this will be 5 pi over 6, because this will reduce over here, the 12 and the 10, and this will be the sine of pi h over 12 as my temperature changing with respect to h that they asked for. All right. So thanks for watching. Hit that like and subscribe button. Give me a thumbs up for this. And then I'll see you guys in part 7 of this series.